Hello everyone, today we're looking at an introduction to probability. We're going to look at a few key elements associated to the area of probability and then look at a few questions afterwards just based on this introduction. On the right hand side I've got a few key elements of notes we're going to touch on, and on the left I've got a probability scale which we will start with. Now, probability is effectively a method that tells you how likely an event is in taking place. You might have seen previously, for example, the probability of flipping a coin and getting heads is a half. You might have heard phrases like there's a 50-50 chance or a 10% chance, and other elements associated to that. Now, if we bring it to the left-hand side, I've got what we call our probability scale. Now, if something was impossible, you might say that there is a 0% chance of it happening. So something is impossible, we give this a probability of 0 or 0%. Whereas if something is absolutely certainly going to happen, we give this a probability of 1 or 100%. Now, what have you got below over here are some different coloured counters effectively drawn on, which we're going to use just to kind of explain these values over here. So, for example, I've got five orange counters, 3 black counters, and 2 green counters. And if I was to take one of these counters at random without looking, or point at one without random, what would be the probability of picking a blue counter? Well, to get a blue counter is impossible. I would have a 0% chance of that happening, or the probability of that would be 0. Whereas if I wanted to take one at random, and then what's the probability that I choose either an orange, a black, or a green? Well, that's all of my options, and so therefore the probability of picking either an orange, green, or black would be 100%. Now, in the middle of my probability scale, I have this phrase called an even probability or an even chance, and that effectively refers to a probability of 0.5 or a half or 100%. Some people sometimes put the phrase equally likely in the middle over here, and although having a 50% chance is equally likely, it doesn't always correspond to 50%. For example, if you roll a dice that is fair, the probability of getting any number on those dice is 1 out of 6, and each of those are equally likely, but the probability of that is not 50%. So we refer to 50% being an even chance. So I should have said 50%, not 100%. 0.5, a half, and 50%. Now, the reason I've written it like this is actually comes to our second point over here, is that probability can be written as a fraction, decimal, or percentage. That is the correct way in expressing probability. If you hear the phrase 50-50 or a 20-80 chance, that's not a probability, that is a ratio instead. So when you are dealing with probability, you have to give your answer either as a fraction, decimal, or percentage. Now, the way we calculate probability is using this little formula over here. The probability of an event, which we're looking at, refers to the number of successful events out of the total number of possible events. And this is where we can use this to our benefit. If I was to say, what is the probability of me picking one of these at random and choosing an orange one, the probability of getting an orange, we write with P brackets O, is equal to the number of successful events, where there are 5 possible successful events out of the total number of possible events, which is 10. So the probability of that is 5 out of 10, which is equal to a half, which is the same as 0.5 or 50%. So any of those values would be okay, a half, 0.5, or 50%. Then if we look at the probability of getting a black, well, this would be P brackets B for black. There are 3 possible events, so there's 3 successful events out of 10 possible events, which gives you a value of 0.3 or 30%. And then finally, if we look at the green, the probability of picking a green is equal to 2 possible events out of 10 events in total, is equal to 0.2 or 20%. So this is our correct notation which we look at in terms of the probability of something occurring would be the number of successful events divided by the total number of possible events. And actually what we can see for the next line is the probability of all events add up to a certain value. If I add these values together, 50%, 30% and 20%, I get 100%, which referred to previously as all possible outcomes being certain. In the same way, I could add 0.5, 0.3 and 0.2, or 5 tenths, 3 tenths and 2 tenths, and I would get a value of 1 or 100%. So either of those are okay. Now we're going to use this information on our next slide just to kind of get us to work with this and then look at this key phrase over here referring to expected value. So what I've got, I believe, on the other side is a table, and the table of values shows us 4 possible options for a spinner. Now the spinner can land on either yellow, blue, pink and red, and the probability of occurring on each of these is 0.35 for yellow, 0.4 for blue, 0.1 for red. But we have a missing value here for pink, which we don't know. Now for pink, what we do know is that the probability of all events add up to 1. So I could add all of these up and see what I need left over at the end to make 1. So if I add 0.35 plus 0.4 plus 0.1, I get a value of 0.85. That means to work out the probability of the pink, so probability of pink, that is equal to 1 minus 0.85, because that's what I've got left over at the end. And that gives us a value of 0.15 over here. So we've just simply used there the fact that the probability of all events add up to 1 or 100%. Now, we now come to our last question, and this comes to this phrase over here, expected value. It says, if the spinner is spun 60 times, how many times would you expect it to land on red? Well, the probability of landing on red is 0.1 or 10%. So that means we should expect it to land on red 10% of the time. So if I've spun this 60 times, then 10% times by 60, or 10% of 60, is the same as 6. And that would be the number of times we would expect it to land on red. Now, it won't necessarily land on red 6 times, but it's what we expect due to the probability. Effectively, what I could write here, instead of writing 10%, is I could have written 0.1 times by 60, because that was the value in here. And we can see that what I've done here is I've multiplied the probability, which is red, which is 0.1, and I've multiplied that by the number of times we spun the spinner, or the number of trials we did. And so when we come over here to our formula for expected value, we can write this as probability is equal to, expected value is equal to probability times by number of trials, or number of times you do something. And if you multiply those two values together, you will get the expected value. And so that is our key overview for probability. It refers to how likely an event is. It needs to be expressed as a fraction, decimal, or percentage. It can be worked out by doing the number of successful events divided by the total number of possible events. And then the probability of all events add up to 1 or 100%. And then finally, the expected value, the probability of something that you expect to happen, is the probability multiplied by the number of trials, the number of times that you do that specific event. Anyway, I hope that's made sense. If it hasn't, please leave a comment below or message me directly. Hope it's made sense. Take care. Bye-bye.